really useful for me to be able to understand where people are at and where people are getting stuck. You should. I mean, if you haven't, then it's okay. But what I wanted to say is there are definitely some people who haven't, worked through everything on there. It's okay if it's like, I just haven't quite had the time. But if you're not working through stuff because you're stuck for any reason on the stuff on rebel.it, there's a lot of different approaches you can take. You can just post something in Slack to let us know, hey, I'm having a hard time solving these problems. But you can also, inside of the tool itself, you can try and submit something or request feedback or input if you're stuck on a problem. So you can send it off and say, hey, I want some feedback. And it will notify me with a little mark that says, hey, I'm looking for feedback on this problem. I can put some extra comments there and send it back to you to try and help you work through the problem. So it creates this opportunity to do like a back and forth as where you're working through something as well. So don't be intimidated with, I was trying to solve it, wasn't able to get it solved, so I just stopped. Like, the more of that back and forth you have, the better it's going to be, both for me to be able to understand what are the obstacles to it, and hopefully for you as well. And there's a very good chance that some of the problems are not worded clearly. They're worded with too much domain knowledge, too much knowledge on my part about just using programming terminology that I've been engrossed in so much that I'm not thinking, oh, how do I convert this into language that's going to make sense for somebody who doesn't think in these terms yet? And those are some of the things that's going to be a lot easier for me to learn if people say, ask for feedback, or instead of just getting stuck and not working through them. Yeah, I see people chiming in as usual. If you're attending remotely, please speak up right now so that we can go ahead and get an attendance count. It would be really useful to know those numbers. But yeah, I'll be getting out more stuff. My goal with it is usually to have it be stuff that you should already be able to solve, but I may put some things in there that you could solve with the tools that you've learned, but may require you to stretch your thinking in terms of how you've applied those tools, right? I'm not going to give you a problem that, like, for example, today we're going to start talking about objects. I wouldn't give you a problem dealing with aspects of objects that we haven't taught in class, but I may give you one that challenges the way that we've used them. It's like, oh, you're using this same concept in a different context or in a different way. There's a good question, though, about due dates for people who are remote. She was asking if there was a due date for the rebel.it homework. I don't have anything on it for a due date. I think I could set them. Yes? You don't think you, what? Let me see if I can, I don't know if I can. I'm gonna step off for just a second. I'll be back. Matt, can you log into you have the account, right? The rebel.it one? Yeah. So I'm gonna step over to you and we'll just choose one of them and have you, I'll step over with you, we'll walk through it to get it set up, and then I can explain how to do the request feedback and show them what it looks like up here. Because I can't remember how to do it, and I don't know if I can sign up for my own class. I don't think I can. So I'll be back on the video in a second, or yeah, you can step up here. And we could screen share with the class. We won't be able to do it online if we want, but let's see what we can do here. So you should be in the class, right?
Yeah, these things change like depending on like where.
I know. If you go student, it should show up.
So should I go here?
Yeah, go there. So if you're working one of these, let's just choose any of them. It doesn't matter. So I think what you can do here is if you just try clicking submit. And then click submit anyway, maybe? What's wrong? What's this? What's wrong? I want to see for a second. No, click submit anyway. So let me see what happens. Trying to get a feel for this real fast. Let me get out of the broader one. So I don't think that that's the real way to do that. Let me see here. I think there's a way to request actual feedback. It might be from the dropdown. So I sent it back. If you guys see what I just did, I sent it back. But let's try it one more time. You should, if you refresh that. You should see that guy. Try it. What do we have here for the run? What's the drop down there next to it?
Oh, the drop down.
The drop down. Run tests. You fail. Show details. No. Yeah, I'm not sure exactly.
So, like, did you provide feedback?
I can.
Oh, but she's asking how she can
request feedback.
What's this talk thing?
That's different. They've got a whole, this is like a sub portion of their site. So that's what I was checking. So I'm thinking, I think the easiest way to get feedback, all right, I could be wrong here. Maybe, yeah. If we find a better answer, we'll get one. But I think the easiest way to basically request feedback is to just submit it, even if you don't have a solution. And it'll show up here. Like if you want to submit that one again, I'll be able to show them what we're talking about. Right. So tell it you want to submit anyways. And I should be able to see that you've submitted that homework, and then I'd be able to see, like, if you've got stuff in here, I can see what your code is, and I can write a message that says something like, oh, typos, right? Declared using 2 brackets. Right, and then I can send it back, and it can be that sort of conversation where they'll be able to see that feedback that I gave them.
Yeah, I see that in my end. I see differences.
Yep. So that's one of the things that makes it really nice is if you're stuck on something, you can just send it anyways. I'll be able to see what's going on and be able to give you some feedback saying, oh, here, looks like maybe you're stuck with this aspect of it. That's a good question because I haven't done that in quite a while, and I wasn't sure what the actual workflow was to request feedback. I think I swear there is one that explicitly is like a request feedback workflow, but I'm not sure. Could be wrong. Any other questions about that, like REPL.it or anything along those lines? Very good question. No? All right. So today we're going to go over basically 3 different concepts. We're going to talk about scope and what it actually means. I know that it's come up before a little bit, but we haven't dug into what it means. We're going to talk about the difference between reference versus value. And I'll be honest, this isn't actually, this is a loose area. This term, I'm using it because it's what's most common in the industry, but it's not a perfect analogy. It's not a perfect example of what actually happens in JavaScript, but it's close enough that you'll be able to understand it. And it's what you'll see way more of than the more actual underlying concepts. And then we'll start talking about objects and working with them. We're not going to get into a lot of the advanced aspects of objects today, but we'll just start creating some very basic objects with some properties and stuff. So we'll talk about scope first. And scope is, it's just the area within a program where a variable is accessible. That's the definition of scope. I'm going to see, by the way, since when I do slides like this, it might be useful. I'm going to see if I can get these converted to, say, a PDF and get those uploaded to the page too, versus just the markdown, so that if somebody wants to have PDF version, they can do that. I don't know if I'll be able to get that to work or not. There's a plugin that's supposed to do it, and every time I've tried it, it's been buggy. But So what does this mean? What does it mean it's the area within a program that a variable is accessible, and what are different areas, right? So in this context, we've worked with 2 scopes so far in class. And we haven't really talked about what they are, but does anybody think of one of the scopes that we've worked with where a variable is accessible based off sort of some of the stuff that we've talked about?
Function.
A function, exactly, yep. And there's one other one that's sort of implicit almost. Array? Yeah, no? It's close. What? Yeah, I mean, you're sort of there, and it's because we haven't really referred to it by anything. It's what's known as just the global scope. It's stuff that isn't inside of some other scope. That's in your global scope. So most of our functions, when we write variables right at the top level of them, that's the global scope of your function. Those variables exist in the entire scope of that running code. I said function, didn't I? The entire scope of that program, there's no separate scope, and then the other one is the function scope that we've encountered. And what does it mean that these are different scopes? So functions create their own scope, and the code outside the function doesn't have access to this function scope. So they can't access anything inside of that function directly. And that also means, as we saw when we were working through some stuff last class, is the parameters of a function are temporary. And they cease to exist after we exit the function. They don't stay around at all. They're just there, and then when you exit, they're gone. So some of the rules of how scope works and what this means is a variable name has to be unique within the same scope. You can't have multiple variables with the same name in one scope. So if we were to look at an example of what that means, just at even the top level here, we can create our do it this way, greeting. Good morning. Saturday. And let's create another one. Too early for me. I don't know. And I don't know, we just want to see the greeting, right? Print it out. But we've got a little bit of a problem going on here, which is we use this same variable name, and these are both in the global scope. In a lot of programming languages, this would actually throw an error at you because you redeclared a variable in the same scope. JavaScript, it's a little dependent on the way that you declare the variable as to whether or not you're going to get an error when you do this. But the key is we don't have 2 different greeting variables. We can only have that one variable name inside of that scope. Got some background music. It's cool.
Is JavaScript case sensitive?
JavaScript is case sensitive. That's a good question. So if we talked about that in the very first class, but we can revisit it. And that's an important thing. I've noticed it in some of the homework too, where people, I'm not sure if they understood that. They were using some weird casing in cases. And so either they understood it or it was sort of a bypass of some stuff. So now we should have 2 different variables because they have 2 different cases for their name.
I would say, even though that's true, it is really bad coding practice to use the same name with different keys.
Yes.
Capitalized or small case, whatever the case is.
This will.
It's really frustrating to work with people who use the same variable for other things. You can really confuse people with collaborating, or even yourself later.
Yeah. Yes, that's why it's very useful to stick with a common naming convention when you do stuff. I've said before, so a lot of times when you're naming variables, you'll put multiple words together in your variable name, and since you can't have a space in there, the most popular convention in JavaScript is what's known as camel case. So camel case is something like where every word after the first one is capitalized. Let me think of a good example of a variable name. Is user logged in? That's this camel case, this convention in JavaScript. We started with a lowercase one, and then every word afterwards is uppercase. There's no rule that that's the only way you can create variable names, but I would say it's the majority of JavaScript code is written using that style, so it's probably best to just stick with it versus using a different convention. That same concept exists inside of a function. You can't have multiple variables with the same name inside of a function. So if I am going to this one's a little more subtle, but now I need to call my function, and I'm just going to pass good morning directly in. And in the same way here, we've got message as a parameter, but because we then declare a local variable message, we can't have both of those in this scope pointing to different things. So message is the one that ends up being used. It basically just changes the value in that variable name. The next rule about scope is scopes can be nested inside of other scopes. And this is another prime example. We're already seeing it right here where we've got a function scope and an outer scope as well. So this is anything here is the global scope. So greeting is defined in the global scope. That's this function. But message is defined only inside of this function scope. It's nested inside of it. And what does that nesting end up meaning? That nesting means certain things. It means code in an inner scope or nested scope can access variables in the outer scope. So if we step back to this bit of code here, I'm going to change how this works. We're not going to pass a message in. And I'm just going to define a message out here. We'll call it good morning. And then I'm going to call greeting. There's something weird about this code, which is that this message variable that it's referencing doesn't exist in this scope. Right? There's no message. We don't have a parameter. We don't have a local variable. It doesn't exist inside of that scope, but it has access to it anyways. And that's because it can access the variables in this outer scope when we call the inner scope of greeting. This isn't probably the most common thing for you to do. It can lead to, in a tiny case like this, you're thinking, oh, that's really nice and easy. I don't have to pass something in. But if you are writing, say, 100, 200 lines of code, and you're writing a function, which is intended to be sort of a self-contained thing that can be reused, if it's implicitly referencing variables inside of the outer scope outside of it, and those aren't passed into it, then it's very hard to know what context you need for that function to run. Like how much of this other code is required for me to run this function. So usually you're going to pass the stuff that you need into a function as opposed to having it reference stuff in the outer scope. But there are definitely patterns where this gets used. Does this make sense? Want another example or something? Here's a weird one. Let's do like our add, right? And I'm just going to pass in just one variable, and then I'm going to return a plus b. We're going to change this code. We're going to define b in the outer scope as, I don't know, 42. Then add, and I'm going to just pass in 100. When we get back, when we run that as 142, that's just because add has one local variable, which is this parameter a, and then when it tries to reference b, we could talk a little more in detail about what happens when it tries to, well, you'll see that, I'll do that on the next rule, actually, we'll talk about that. So it tries to reference b, and it gets it from the global scope, and then it adds those two together. Yes? So it's not necessarily, the rule would be, again, it's worded specifically here in an intentional way where it says code in an inner scope or nested scope can access variables from the outer scope. And that's because you won't always just have, this is a little bit like it's turtles all the way down. Anybody's heard that joke? You can have multiple layers of nesting of scope, and they'll be able to access the variables in any scopes outside of or layer up, barring pretty much the next rule. So there's nothing that, at its most basic level, the answer is no. Some of the newer JavaScript approaches, there's something, and we don't need to get into this right now, we'll talk about this in a later class. JavaScript now has a concept of modules, and that's where, usually in JavaScript, it doesn't matter what file your code is in. If you load all that in the browser, everything at the top level is in the same global scope. If you have actual modules, then each file is its own module, and they don't have global scope, they have module scope. So it's another type of scope. So then they wouldn't be able to necessarily access those variables, but there's nothing that, there's no like, oh, you can't access this variable in this higher level scope that you would normally have access to because it's named something, except for the last major rule I want to talk about, which is unless you reused a variable name in both scopes. In that case, the outer variable name is said to be shadowed and can't be accessed in the inner scope. And this one, I'll do this coding example, and then I'll step over to that Python tutor, which I think will help visualize it a little better about what's going on. So let's go back to the simpler version here, this just greeting. Or greeting back, rewind, keep rewinding. All right. Here we have a message, good morning. And then I'm going to also pass a message into my greeting. So that will be creating basically a variable in this function scope. And so when I call greeting, I'll say, I don't know, need more coffee. They're cranky, right? They're like, need more coffee. There we go.
Hold on, what do you guys think will happen?
Yeah, I was just gonna pause.
Why?
Because you're not like doing any constant but you are doing it constant. Said that in reading.
Now I added one more line too.
Okay. Now we will say need more coffee.
Anyone think it'll do something different? Yeah?
Need more coffee, and then a second line
Of Ugg need more coffee. Okay. See what happens? And we get, yeah, okay. Ugg need more coffee, and then good morning. So let me throw this over into this JavaScript tutor tool, which I think will help us visualize a little bit better what's going on here. There we go. I can zoom in some. So if we look at where we're at, right, we didn't run the function. It evaluated it. It's ready to run it, but we haven't run anything. And here in our global frame, we have this greeting variable that is really just our function. And then we have an undefined message variable. We take our next step, and here we have a message variable, which is just a string good morning. And we still have our function. We haven't gone in there yet. We go into our next step, and now we're inside of our greeting. These are each one of these here that they're calling frames. That's what JavaScript typically calls scope. There's, again, slight differences, but it's pretty close. So now we're inside of greeting, and notice in greeting we have message. Need more coffee. And so on this line, this console.log, what it's actually going to do is it's going to come over here and say, oh, inside of my closest scope, does this variable exist and can I reference it? Do I have a variable name called that in the closest scope that I have? Oh, I do? Then I'm going to use it. And then I'll show you the add one again in a second. What happens there is it'll always go, oh, if I don't have that variable name in this scope, then check the next scope up my stack. Check my outer scope. And then that one will say, oh, I don't have the variable name here. Oh, check the outer scope. Oh, I don't have a variable name here. Check the outer scope. And just keep moving up, trying to find that variable name that it can pull the value out of at some point. So now when this runs, it doesn't return anything. It prints this out. When we come back down here, and that, as we said, that whole function scope ceases to exist. It doesn't exist anymore. So down here now we've got message, which is this string good morning, and it prints that out. And that's because we masked that scope about what was going on. Now there's some weird gotchas. That's what we'll get into in a little while when we talk about reference versus value types and how some of that stuff works. That's going to really be confusing. It'll take quite a while for you guys to wrap your head around what the differences are there. But so it makes sense how you can sort of mask stuff or shadow it by using that same variable name. And that's something that you don't necessarily do explicitly. You're not going like, oh, I intentionally want to use this same variable name. But unlike where you really don't want to use variable names, the only difference is their casing. This will just happen in your code sort of by, it's not by like, oh, I shouldn't have done that. It's more just, oh, this variable name is the most meaningful name in this function, so I named it that. And in this outer scope, it's the most meaningful name to have it that way. So it makes sense to have it sort of shadow that variable name. Okay, let's see. Any questions on scope and how this stuff works? Some of your homework will probably have you work with some of these concepts. Maybe I'll have some buggy code that uses scope wrong. In the function. So if I took this and instead of passing message here, I declared it. So I said, like that. It's essentially going to be the same. Oh, wait, I have this wrong. Hold on, I want to keep that there, and then I don't need to pass anything in. It's essentially going to be the same. The difference is, what I would say is the difference between passing something in as a parameter and it only existing in that function scope as a result of being a parameter versus being a local variable inside of the function is inconsequential to understanding JavaScript as a language. It's very that's a very low-level concept that only the people who are probably building the language care about the differences between a parameter versus a local variable. There are some cases where it would matter if you declared it in different ways, but for the most part, it doesn't really make much of a difference. It's a good question. Any other questions on scope? Anything around that?
So is that kind of like, you talked about how the for loop sort of like more conveniently encompasses the components of a while loop. For the function, it's almost like when you pass in a parameter, it's like declaring a loop.
It is, yeah. He's
a shorter way of writing that same thing.
Yes, the statement was like, we showed for loops in the last class, and I said a for loop encompasses all of the logic that you do when you're doing a standard loop type while loop, because you've got your initialization, your conditional check, and your updating your condition all grouped together on one line. And sort of how that's syntactic sugar, being able to pass in parameters into a function, that can be like a little bit of syntactic sugar, but it's also useful because you get to pass values in, so it makes it flexible. It makes it able to do different things, right? So the other big difference here is that is a good point, right? There's not a difference in terms of the scope for the most part, but the difference is now this greeting is hard-coded. It can only ever give one message. Whereas if we went back to what we had where rewind and we pass something in, now we could call this same greeting with different strings and reuse the logic inside of it over and over with different values. And it doesn't matter that much here because we're doing one thing, but it'll matter a lot when you make stuff more complicated. So parameters are really one of the most important ways that you take code and make it reusable, because what you do is you take something that's specific, you sort of extract out what are the things that can be variables and change if I did this over and over and still want to do the same thing. Make those parameters to your function, and then you can create a function that lets you write something generic that can be reused as opposed to something specific, right? That's a little bit like if we did, if we were writing the add, it's going to seem very, going to be lazy here. Copy this a few times. If I was trying to log out 1 + 2 and then 3 + 5 and 7 + 11 and 13 + 17, you could do that, but then you might say, wait a minute, I'm doing this same pattern over and over again. I'm adding 2 things, and the only thing that's changing is what the values are. And in this case, yes, I'm not doing a lot with them, right? It's not that incredibly complicated. But you might say, it's so much nicer now if I can do add AB. I've created something generic. And now I can take each one of these and just pass the values in and reuse this add logic. I'm going to make this more complex just for the sake of showing you where you get more value. Is there a question? Okay, I'm going to make this more complex just to show you like where you get more value out of that. But let's say you weren't doing add. Let's say you were doing something much more complex with the numbers that you pass in. What you want to do for each one of these steps. So I'll just rename this. I'm just going to call it compute to be generic right now because I don't know exactly what I want to do. But for each one, let's say what you wanted to do was you want to add them, and then you want to find out what the modulus, like you want to divide them by, I don't know, 3 for whatever reason, and return just the remainder of that. mod 3, and then you want to return the remainder. Now you're getting to, by turning this into something generic, you're getting to reuse all of that logic with those same values, and you didn't have to write that stuff over and over again. And that's the value you get from parameterizing. That's what it would be called, like parameterizing your function or parameterizing your stuff is, oh, I looked at my stuff, saw what was common and what was different, turned the thing that changed into parameters so I could make a function out of it, and then I can reuse that over and over by calling it. It's a good comment. Good discussion. Any more questions on scope before we move on? All right, now this one takes a little bit to wrap your head around, this set of concepts. We're gonna talk about it. You guys really haven't had to deal with the differences here. I'll show you some of it. This one's gonna be one of those ones that's more, you're gonna have to read on it. You're gonna have to practice it. It's gonna take some time. And that's the aspect of sort of reference versus value. I don't know if there's a good explanation for this that makes sense across the board, but the short explanation is a reference is a pointer to a location in memory where a value is stored. So I'm going to go back to this bit of code that we have here, where we had our little greeting here. Is there anything, if you were to look at this page and just not even knowing what the definition of a pointer or anything is, does anything look like it would qualify as a pointer on this page anywhere? Greeting, right? You've got something that looks like it's pointing somewhere. Just by the fact that it's pointing there. Oh, this doesn't look like it's pointing somewhere, this message, but this looks like it's pointing somewhere. That's what, I mean, probably the best real world. I really like how they show it that way because it helps visualize sort of what a pointer is. And it's pointing to, in that case, somewhere, another place in memory where this value of the function is stored. That's what's going on. And we'll emphasize that a fair bit more. In JavaScript, whether a variable is a reference or a value is determined purely by what type of variable it is. Again, I'll go back. If anybody's a real purist on the language, reference and value are loose definitions. This isn't the perfect explanation, but it's the best that I have that doesn't get into really complex descriptions. So what determines a reference versus a value when you pass stuff around is the type of an object. So let's do a pop quiz. What types have we learned so far in JavaScript in class? Ooh, what do we got there? That was a good list. Boolean, number, string, undefined, null. I think that's what we got. Boolean, number, string, null, undefined. That's what we've learned so far. What's that? We'll get there in just a second. So for the primitive types of Boolean, number, string, null, and undefined, JavaScript always stores the actual value in a variable. It's the actual value that it's storing. And then there's only only one other actual type in JavaScript. Well, technically there's two. As of ES6, we have something known as symbols, but we're not going to deal with those in this class right now. Traditional JavaScript up through ES5, there's only one other type, and that's objects. So we've covered all 6 types in JavaScript now. You've got Boolean, number, string, undefined, null, and objects. Once you've got those are the types in JavaScript. And then, like I said, symbol. If somebody's quizzing you today, like if you go and do a job interview and they're like, oh, you missed symbol. Nah, you're being a smart aleck. So objects are the sole reference type in JavaScript. That's where it stores a reference to the object in a variable instead of that value directly. And this leads to some very different behavior between the two types. It can be quite confusing when you are first learning JavaScript or any other language with similar behavior. It really can. The most common example of the difference between the two types, a reference versus a value, is what happens when you pass a value of that type into a function. So when you pass a value type into a function, it creates a copy of that value with the appropriate parameter name. And this means that if you modify the value of that parameter in the function, it doesn't affect the value of the variable outside of the function. So let's do an example of that. Let's do a hands-on work through. We'll go back and create this add, or you know what, we'll do this message because this one's even simpler. We've got a message outside and we pass. I'm going to change this. We're just gonna change what I pass in here to be nothing more. But what we're going to do here is actually change this message. Oops. Habit, force save after every change. Inside of here. And if we go to our visualize execution, it should be no surprise. We've got good morning out here. We go into our function, and inside of this scope, it has its own message, which just says, ugh, right now. And then we're going to add this need more coffee to this message inside of this scope and print it out and come back out. And it didn't do anything with what was this message out here, right? Now that by itself probably makes perfect sense. You wouldn't have expected anything to change with the item outside of the function when we added something to it, right? So I hope that that part makes perfect sense. It's the next one that's going to be the confusing one. And I'll show you an example. Again, I won't expect you to totally understand exactly what I mean immediately. We'll work through a lot more examples over time. But however, for reference types, it doesn't actually copy the value in the function. Instead, the parameter in the function refers to the same value. So let me show you that real fast before we change anything. And this is going to be a little bit different. So an array is actually an object. That's really the object that we've worked with the most. So I'll use an array here as an example of something. So we'll do like, what are some primes? 3, 7, 11, Optimus. Really? Yeah. Bad joke. I appreciate that I got to laugh at my bad joke. So in here, we'll list our primes and we'll call it primes. Why not? Or let me make it so that I'm not masking it. We'll call it list values, and we'll just call this values. I'm going to use our nice little for loop that we learned about last time. We'll start at 0 as long as we're shorter than values dot length. Let's print this out. Oh, I just did I, right? I'm being very lazy. I should call it index. And then we need to call this. Oh, I've got a bug. Oh, yes, I do. I do have a bug. Let's see if it's working now. Oops, still missing something? Oh no, that's just yelling at me for my previous bug. All right, so if I step forward now, you'll notice here that this primes, unlike the string, it doesn't have the value listed right here. It looks like a pointer, just like this function did, right? We've got an arrow pointing somewhere else to this array. So when we go into list values, what you see here represented is that inside of this list values, we have a values variable, but it also doesn't have the array right here. It has a pointer pointing to the same array over here as this global primes thing. So they're actually pointing to another memory location. So it copied that memory location and said, oh, you also point to this same piece of memory. And the reason that a programming language does this is that because it's very inefficient to copy everything every time. Imagine, if you will, that this array, instead of being 4 items, was 10,000 items long, right? And you want to be able to pass it into a function to work with it. It would be very inefficient for it to copy all 10,000 items in memory and send those into that function, because it has to duplicate all of that stuff in a second location. It's much easier for it to say, oh, I know where all 10,000 of those items are in memory. I'll just point you at that position, and you can use that same stuff. So now it's going to walk through the code, referencing each item in the array, printing them out, blah, blah, blah. Optimus Prime. And then we're good. So that's the idea of sort of this reference type. It's not a copy of it. It's not passing the value, it's referring to that location in memory. So far, does that make sense? You're mostly following? All right, so here's where it gets tricky. This means that if you change values in what the variable refers to, it will change in the function and outside of the function. So I'm going to go back here, and we will put another example here where in this, before we run our list values, we're going to change the one in the first position, and I don't know, I could think of another funny prime pun, but I don't have any. Ooh, I like it. I like it. It's a good one. So we'll change it to this, right? All right. I don't have a syntax error still. I fixed it. And what I'm going to do down here, a couple things. I'm going to log the value of prime 0 right now, just so we can see it. Then I'm going to say, I'm going to put some nice messages here to make it easier what's happening in the console. Following list values, that way you'll see the order of everything. Exited list values. Primes at 0, and we'll print out this value. So what do people think is going to get printed when we run this program? What's your guess? You can take a minute and talk if you want to, try and figure it out. Any guesses? You can start with one line at a time. What do you think the first thing is going to get printed is? 3. All right. Let's write this stuff down. Let's take our guess. What are we guessing? We think it'll be 3. All right, and go back. No? Rib, all right, maybe. All right. What next? Next thing printed out. Calling list values. All right. And what do you think will be the next item printed out in this? All right, so the guess now is rib, 7, 11, Optimus. Exited list values. I think I have that uppercase, which is weird because I didn't do the other one that way, but whatever. I did do the other one that way. All right, and what do you think for this last line? Did I hear 3? I saw someone say 3. All right. Let's go with 3. This is one of those things. I really like that Matt helps emphasize doing this too. I really encourage you when you're doing code to do this exercise. Like this should be one of your exercises is before you run your code, take a guess as to what your code is going to do, run your code, and then say, did it match what I thought was going to happen, right? Write it out like that, especially if it's something small. Oh, this is what I expect it to be, and did it match that? There's actually a more formal, we'll talk more about this later, or maybe a whole nother class just dedicated to it, but there's a much more formal process around that, that's not me just encouraging you to do it to learn code. There's something known as test-driven development, where you literally write code that says, this is what I expect my code to do, and then you write your code to get your code to actually do that. So you're writing code that says, my code should output this, 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 and this, and then you write code to make sure that happens. This is a little different because what you're sort of trying to do is learn if your assumption about this code is correct. That one's more validating that you're writing code, your code does what you need it to do, but it's a very similar concept. So let's see what happens here. Now we're pointing at 3, 7, 11 Optimus. And remember, we haven't run any of list values yet. It's defined this function, but hasn't run any code in there. So it prints out 3 because that's the first value in our array right now. Calling list values. And now we jump up into here. And when we change this value to 0, you notice it changes it over here in this array that everything's pointing to. So it didn't change anything specifically local here. This still points to that same array. And if we step through, we'll read the array. But this is the interesting part. If we jump back down here, the array still has those same values. And that's because both of these variables, the one that was in here as values and primes, were referring to the same array in memory. So when you change the value, it changed it in a sense for both of them. It changed it in this context where they were both pointing. This is going to take you a while to get used to. This is a challenge. This is a challenging concept. It's not something that's going to just click immediately for most people. It's going to take a fair bit of, it's really nice that tools like this exist now, because I have spent years and years writing stuff out on paper. I'll write out on paper, okay, this is a pointer to this over here. Here's my memory. Like, I write out pretty much that exact same visualization that it had there. I write that out myself a lot of times when I'm trying to figure out how something works. So it's nice that there's a lot of tools to help out with some of that visualization, but practice it yourself too, writing out that sort of structure on paper. This is a really nice GIF I found. Probably get in trouble for just hijacking it from there, but it's sort of showing the difference, if you will, of a pass-by reference versus pass-by value, where on the left, if you see this as a reference to the original cup, hence the dotted line, when you fill it up, it fills up that sort of cup. But on the right, if it's being passed by value, well, it's a new cup, so it doesn't fill up the original. It's not a reference to the same thing. Any questions on this so far? So I'm going to show you one more example on this, and then we'll take a short break, come back and start talking about objects. This is to help show you that it's not always so clear cut. So this might be confusing as well, but I want to sort of emphasize it a little bit. So here I'm going to say values equals. Just do that. Oops. So what do people, let's take a guess here, because I'm doing something that's intentionally, this should intentionally be confusing and maybe throw you. If we already have what our previous guess is as to what the code printed out, and this was correct, what do you think is going to get printed out when we run this code? We can do it line by line again. That first console log at line 9, what do we think? 3. And then I heard calling list values, all right. Now what do you think will get printed inside of list values? All right. And now when we come back out on line 12, exit in, right? What about line 13? What? Rib? That's our guess? All right, let's see what happens. And this is sort of, I hope this works the way I expect, but this should show you how this is pretty complex and there's actually a lot going on. So we're gonna, all right, we've got this array. We're gonna call up into here. And right now you notice they both point at this same array. Ooh, what happened there? Anyone notice what happened after we ran the line, this line here? Didn't change the values in the array. Yes. What happened is it's not pointing at the same array anymore. So we can change the whole array that this local variable points to. It's now pointing at a whole new array or a whole new object. It created a new one and pointed at that, which means that now it's no longer pointing at this one, and so its changes aren't connected to it. So the difference between those two different versions of the code that we wrote is the first one was using the existing array and changing a value in it. This one put a whole new array into this values variable, hence why it points to this whole new array now, instead of changing what was pointed at before. And so if we step through it, we go ahead and print out all that like we expected. But then when we exit, our original prime still points at the original array because the other one didn't exist in that scope. And this is one of those ones, don't worry if you don't fully grab what's going on with that, right? The part of the point of that is to show that it's very complex as to what's happening. And it's going to take you a fair bit of just work outside of class, not just sitting here, most likely, to try and internalize how this works. You're going to have to work through some of this. But what was going on there essentially is it created a new array, and now it pointed at that new array instead of pointing at the old one.
You guys are having trouble understanding this. It's really counterintuitive to me. This is not how R works. This is really weird. So if it takes you a while to pick up on this, I think that's totally fine.
Yeah, that's a good point. He was saying this is not how R works, so it's very counterintuitive. What I can say is this is one of those concepts that you have to, the idea, that's why I use the terminology that's pretty common between programming languages of reference versus value types and working with that. You'll hear that terminology used pretty commonly, but the way that that works in different programming languages can be dramatically different. So you can't assume that the way it works in JavaScript is the same way that it works in, pardon me, say Ruby, if you're familiar with Ruby, or the same way that it works in C, if you're familiar with C or C# or Java. Each one of these programming languages operates on types differently. Sometimes in them, like in some programming languages, you can explicitly tell it, ooh, I want to use a reference instead of, even though this might normally be a value that it would pass around, I want this to be a reference to it so that inside of the function, it refers to the same place as outside of the function. In some programming languages, you have no control over that. And so in some of them, it's everything is by value. In some of them, everything is by reference. It really varies a lot by programming language. So it's one of those things you just have to learn for each language that you're working in.
Why is it done like this in JavaScript for like memory optimization purposes, or why do you want?
So what I mean, there is a why, and that gets into the more underlying about how the language works and why value and reference aren't the best terms, but I'm using them, which is that in reality, everything is passed by value in JavaScript. Everything is a value. It just happens to be what is the value that you're passing around. So in JavaScript, sometimes the value is a pointer to another place in memory, and sometimes the value is just that hard-coded value or whatever, the type. And so when the value that you have is a pointer to another place in memory, then if you put another pointer to another place in memory in that variable, then it's not going to be pointing at the same place. And that's what happens when you declare an array like this, is you're saying, oh, here's another, I want to take a place in memory to store all these things, and then this variable now points to that. So you're changing the value of it. That's actually, that's more technically what's going on, is everything's actually being passed around by value. It just depends on what the actual value is that's getting passed. It's just a lot easier to use the more common terminology. All right, let's take, if people want, we'll just take a 3-minute break or something like usual, and then come back and we will start talking about objects. So if you guys, hopefully people thought of some objects at home, have some properties and things of them that maybe we'll get into a little bit.
C++.
Inherit syntax from C. That's all. C++, yeah, C++, you can choose to ask stuff like that, we were reference, dereference. I guess so last time, that was like, that's what they taught us in college. Or the language to teach, it's a programming language. Your personal, there's so much complexity to it. I mean, in the sense that it really teaches you a lot of what's going on here. So confusing.
Do you use it?
I haven't learned C++ in years. I don't know if I've actually written any production C++ outside of college. I mean, I've written toy C++ outside of college, but nothing in production. I've written Java, I've written production C. I've written, now most, if I do backend stuff, it's higher level, C# or Python or even JavaScript.
I have a question about C# class right now. What usefulness does C# have other than and like
I mean, it can be used to build any backend. Like .NET is the biggest thing. Oh, I'll step up here too, but .NET is definitely the biggest thing. The question was about just C# and what usefulness does it have. .NET is by far the biggest use for it, but .NET is, I mean, an incredibly powerful thing. And plus, they have .NET Core now, which can run on any platform, or not any, but Linux and other stuff. So it's really useful to build out a backend. It can build out front ends for like native Windows apps, but there's probably not a lot of that going on. You can even build out a full web app with C# as long as you don't need a lot of interactivity on the front end. If you're just serving up content, there's a lot of nice frameworks for that. But yeah, I mean, that and Unity games are definitely the most common cases. So. I mean, every programming language has its domain that it ends up being used a lot in. And that just, a lot of times it's not even intentional. It sort of evolves. Sometimes it's intentional, like the R programming language is obviously intended for statistical analysis. That's what it was built for. But then you have a language like Python, which wasn't necessarily built to be a statistics / math / underlying language like that. It just sort of happened that a lot of people ended up using it for a lot of that stuff. And so it's also very popular as a math or statistics or AI language. There was nothing implicit in it that required that. So it just, it ends up varying sort of how a language evolves, I would say. It's a very interesting field of study. All right, let's talk about objects. Let's talk about objects. What are objects? Objects everywhere. We already talked about how there's 5 primitive types in JavaScript. We've got string, number, Boolean, undefined, and null. And as I said before, everything else in JavaScript is actually an object. So that's a little confusing, and you're not always going to need to use that knowledge, but it is something worth knowing. Everything else is an object. An array is an object. A function is actually an object. Just everything else is an object. So what is an object if we're talking about them? An object, this is just about the shortest definition I can come up with. An object is an entity that has properties. Very generic, not exactly something that's incredibly practical. But what does some of that mean? An object encapsulates state and function in its properties. So the properties of an object encapsulate the state of an object and function that object, that can be done on that object, essentially, like what functions or
things can happen to that object. State, that's the characteristics of an object. And function is the behavior of the object. Those are called methods or functions that can be performed with the object. So those are the two aspects of an object. You've got state and function. And all of that is just encapsulated with properties. In JavaScript, it's actually really simple, which is, I don't think I even have a slide saying this, but all JavaScript objects are key value pairs. And so if you want a great example, a great reference of what a key value pair is, think of a dictionary or a phone book. A dictionary, you've got a key, which is the word, and the value, which is the definition. Or a phone book, a key, which is the name, and the value, which is the phone number. That's just real world examples of sort of key value pairs that you've probably encountered in an encyclopedia. That's how objects work in JavaScript. It's really that simple, and you'll get to see a little bit of that today. We won't dive super deep into that, but everything is a key value pair at the top level. And that's a useful thing to keep in mind because other programming languages have a lot more complexity about what is an object at the highest level. JavaScript objects are much simpler at that level. So let's talk about examples. We've encountered many objects already in class. Anyone remember what some of the objects that we've encountered and used are? An array. I'll give you a hint. When we've done stuff that's been like something dot something else, or something period, if you want to think of it that way. Math.random is a good one. Dot length is something that you do on an object, yep. And we've got another one that we write at least every class. Console log, right? So here's 3 prime examples that we've encountered quite frequently. Arrays, math object, and the console object. All different objects. So how do you create an object? There's a lot of ways. JavaScript, unlike other, this is a weird one. JavaScript has, I don't even know, I would say probably at least 6 ways to create an object. At least. A lot of languages have like 1 way to create an object. JavaScript has like, I think 6. But the simplest is what's just known as object literal syntax. And this is pretty much the most basic version of object literal syntax you can get. Just your variable name equals, and then 2 curly braces, followed by a colon. So what's created here is just an object that has no properties. There's nothing in the object, empty object, but there it is. So if we were to go over to our terminal, for example, fire that up, we could do that same thing here. Car, and type of car is an object. It's just an object, I didn't mean var there, I meant car. I shouldn't name it something so close. It's just an empty object. It's got no properties, nothing on it, but that's how you create one. So people who are familiar with other programming languages, say C#, that we were just talking about, C++, some other languages, they may be used to having to create an object using the new keyword. That's not the, I would say, canonical way to create objects in JavaScript. Make sure I don't have any other downsides there. All right, object properties. So a JavaScript object is just a type that has properties. That's what I was saying. It's pretty much this key value. Each property is a key value pair. The key is just the property name. And the value of a property can be any type. So what are our 6 types that we know about again? An object. So one of the interesting bits there is I said it could be any type. So the value of a property on an object can also be an object. So you can have properties of objects that are objects and just continue on down. So let's, I'll go ahead and do some hands-on stuff here. So we've got our car object that we're already working with, right? And I think I'll have some slides that will cover this too, but the way that you can just define properties or add properties to it is typically known as dot notation. Let me create it this way, actually. So I'm going to exit out of this, and I'm going to create one with some properties on it. And don't worry, we'll look at the syntax a little more in just a moment. I'm going to create a car, except this time I'm going to include some properties on it. So what are some properties of a car? Some descriptive properties. Horsepower. How much horsepower should our car have? 500. All right. Another property of a car. Color. What should the color be? Silver. All right. Another property. Weight. I'm good. How much does our car weigh? What? You don't know? You know how much our car weighs? It's going to weigh 3,000 pounds, I guess. What? It is a great horsepower to weight ratio. All right, all right. What else we got? Another property of our car. The model. Ooh. I don't think that this exists, so we're going to have to make up our own model name. What's our model? Optimus Prime. Ooh, Optimus. I'm a big fan of this Optimus one. All right. I think that's good enough for now. And so then I'm going to close it right here. So now if we type this car, what you'll see is we've created an object that has some properties on it. They're just key value, key value, key value, key value. Pretty simple. Now we didn't do this in this example, but when the property on an object is a function, so you can have a property that's a function, not just these primitive types that we listed, it's called a method. So you'll probably hear for the most part in class going forward, talking a lot about methods on objects. I won't really refer to them as functions, because that's just the common language of object-oriented programming is a function attached to an object is a method of that object. Basically, whenever referring to a function called on an object, it is referred to as a method of that object. For example, we have frequently called the log method of the console object, right? So setting and accessing object properties. Using the same object literal syntax, we can set properties on an object when it's created. This is what we were just doing. This is just a text description of it. To set a property using object literal syntax, you put the property name or key on the left side, followed by a colon. Then the right side is the property value, hence key value pair. Each key value pair is followed by a comma, just like each item in an array is followed by a comma. So it looks very similar, right? And here's a much simpler one. When you access a property on an object, you use dot notation for the most part. That's just where you type the name of the object followed by a dot and then the name of the property to access. That's the same thing that we've done for console.log. That's accessing that property on our object. Or when we had an array, .length, we're accessing that property. So we can look at any of the properties of our car here just by using this dot notation, and we get back that value. Make sense so far? Going well? We're not going to dive. I think this is where I pretty much have it in for today. We're going to dig a lot more on objects, but I wanted to do some more of the real world ones that people came up with, some of the objects, and just talk about some of that stuff. But before you even do that and jot down some of those and maybe write them in code even, if you were to guess right now, based off what we've talked about for what an object is, where could you see some value in using an object? Like where do you think it makes sense to use objects, or why do you think that this, at least with what you've learned so far, that this makes sense as a concept to exist in the programming language? What's that? Making an app? Yeah, definitely. It's an easy way to take things out of an array. Ah, yeah, that's a good thought. Definitely. Any other thoughts so far? I mean, I don't think there's a right or wrong on it.
Kind of like an instance more specific stuff that whenever like a aspect of like, for example, like let's say it's like SUV, a truck, and a sedan. They're all like the same, but they all have properties inside. Only access.
Yeah, it makes definitely. It's, if we go back, we talked about, abstraction and composition and some of those. This lets with us, an object sort of captures almost all of those behaviors that we were talking about. It's not an algorithm explicitly, but when we were talking about those three concepts, an object captures composition because we're composing it of these other properties. And it captures abstraction because we can refer to this car object as opposed to all of these individual things. So if we were to go back, for example, we've done a good number of homework problems already where we've worked on tax. How much does the tax cost on something? And we had to create individual variables for stuff of what is the category, what is the price. Well, we could create a item object, and that could have a price on it, and it could have a category. And now those things go together. They're connected in a logical way. And if we want to refer to that item, we don't have to have these separate variables that have no relationship. We can work with this item directly. It gives us a nice way to relate things as well, to put related things together and hold on to them. Talk about them as a whole as opposed to talking about all these individual variables and parts. We sort of smash them all into one thing, and now we can pass that one thing around and work with it the same way we can any other variable. Yes?
So the notation for the object of the kind of looks similar to what we use to make arrays. So can I use like an index to refer to the specific component of the object?
And can you use an index? Like, let's try. Let's see what happens, right? Let's say item 0. Get back undefined. Okay, so that didn't work. Now I'm going to pull the item back up so we have it. We know we can do item.price or item.category. There is a relationship there, and we'll talk more about this again in the next class. You can use bracket notation to refer to items on an object. It's not as common. You use it in certain situations when you don't know the exact property name, or you're doing something programmatic, or if the property name conflicts with a keyword, because you can actually give property names. Remember we had that list of reserved words in the beginning of class, for example, where obviously like I can't name a variable var shouldn't work because var already has meaning, and so it's going to mess stuff up. You actually can have properties on your objects that don't conform to proper variable naming. But the way that you do something similar is if I want to refer to something on the item, I can actually use a string of the name. So I could say item price. Another syntax for getting the property of an object is that square bracket notation and a string of the key. We'll do a little bit with both. This one, you'll usually, the vast majority of the time in your code, you're doing dot notation with your objects. I say vast majority. I mean, especially when you're learning. Once you start getting more advanced in your coding, the bracket notation becomes something that you might use. But a lot of times what you'll do is you'll hide that inside of a bit of code, like a loop or inside of a function, because you don't want that bracket notation to be leaking all over the place. If we let's try item.0, what happens? Well, we get an unexpected number because we can't start a variable name with a number, right? But if we did item.foo, we get undefined. So that behavior is a lot like what happened with the arrays. You don't actually know just by doing a dot notation with a property name or a key, you don't know if that key actually exists on your object, because you'll get back undefined if it doesn't exist, but you could also explicitly assign the value undefined to that property. So did anybody choose an object at their place to try and describe, try and think of the different properties of? Yeah. What do we got? A lock? A clock. All right, let's create a clock. We're gonna try and create one here in code. What do we got? Round. Let's do shape. Round, all right. Okay. What are we gonna call that property? Clock face numbers. I don't know. I'm just gonna do a full array. Why not? All right, what else we got? Has minute hand, true. I don't know. Has hour hand, true. Has second hand, true. Ooh, okay. Let's say, I don't know what to, motor. I don't know. I'm just gonna let me call it motor type. Electric. Battery type. Right. I don't know what it takes. Power remaining. Maybe 50%. 5, like 50%. I don't know. What else we got? Ooh, nice. Can hang up. True. Sure. I like it. Create a clock with a whole bunch of different properties. Right? Anybody have a different object? So this will be one of the coding things, which should be pretty simple. It's not going to ask you to do much more than this, which will be, create an object with some properties. So you can choose something and choose whatever types of properties you want to put on it. So part of the reason it's useful to do that is because it does help you relate a programming object to a real world object. Now, they don't always relate one-to-one, but you can see I started with a car here, and I did that because there's a relationship. It feels very similar. Right? We've got these different properties of a car. Now, obviously, a car has thousands of properties, and so we can't realistically here describe all of the properties of a car, but maybe we don't need to. Maybe we can make some assumptions that a lot of cars have all these things that are similar. We can just ignore that, or all we care about in our context are these different properties of a car, and so our car object can represent those different properties. Yes.
What happens if, like, after I create it and then I realize I made a mistake and the clock actually takes triple A battery?
You can, yeah. So it's easy. It's very similar to, remember how on an array you both get the value out and you assign a value into it using the same notation, except just by doing equals. So if we wanted to see what type of batteries we have here, we can get our battery type. Well, we can do the same thing, clock.battery type, and we just give it a new value. AAA, and now our clock has changed. So now it takes AAA batteries. So it's very similar to how the array reused that same notation for reading a value and assigning a value. You do the same thing here.
Let's do a chair.
What?
A chair.
A chair? Let's do a chair. All right, what do we got? What properties do we want to describe on our chair? Oh, like a brand? It's an IKEA chair? All right, what else we got? Now, we'll do color, and then we got to give it a name. And this is an IKEA chair, so it's got to be ridiculous. All right, what do we got for an IKEA chair name? Ivanka? That sounds like an IKEA chair name. I'm sold. I'm sold on it. All right, what else we have? Material. What type of material is our theft? Wood. All right. Weight. It's not 3,000 pounds. It's a little lighter than that, right? What else we got? Number of legs. All right. I'll even say number of legs. 4. Anything else? We could do like maybe there's a style, like it's modern. I don't know. All right. We've got a chair object. We can reference the different stuff on it, find out the brand. Oops. See, I typed it wrong. That will happen. We can read our brand out. You can even, and we'll talk a lot more about this in the next class, I can add another property to this object right now. So one of the things that's going to come with every IKEA chair are instructions. So we see it has nothing right now, but I'm going to just go ahead and put a value in there. Instructions are useless. So, and now we've added an additional property to our object on the fly. So you noticed before I was using this object literal syntax and putting all those properties in when I created the object inside of my curly braces. Another way we could do something like that is just add them as we go. So if we have another object, let's choose a, I don't know. What else should we choose here for an object? Let's do a TV. I'm going to create an empty object. Now let's go ahead and give this television some properties. What are some of the properties of our TV?
Color or not?
And color or not? All right. What else? What about screen size? How big do we want this to be? 48 inches, all right. Another property of our TV? Model. Again, this is a television, so it's gonna have some model number, that's like random gibberish combined with other stuff like SCH48 or or SCP-48 LH3-5B76. I don't know, right? That looks like a model number for a television, doesn't it? Yeah, I'm sold. All right, what else we have? Brand. This is obviously a Samsung TV. I don't know why. Any other properties that we want to add? Resolution. Oh, that's good. What do we have? 1080. Sure. It's not the fanciest new TV. Anything else? All right. So this is sort of an introduction. Next class, we're going to dive into a lot more of objects. We're going to talk about methods on them and starting to utilize them. And objects have some weird context associated with them. That's going to be something that we'll be talking about over the next few classes, as well as some other ways to create objects. I do want to emphasize something before we're done here, which is if you're familiar with objects in a different programming language, try and keep a relatively open mind about how they work in JavaScript and what an object in JavaScript is. So an example I'm going to give here is anyone who's familiar with objects in another programming language, what's the usual way to declare like how you're going to create an object? What's the thing that you create objects off of?
Oh, C++ make a class within the program. You can declare objects and those objects are like instances of that class.
Yeah, exactly, right. So who's familiar with classes? That's basically what was said. Using classes to create objects, instances of it, right? That's the way most other programming languages work for objects. You notice I created no class here to create these objects. I just created them out of the blue, just with this object literal syntax. They have recently introduced a class keyword in JavaScript, but I think it's sort of dangerous because it's not the same thing as a class in any other programming language that you're familiar with. JavaScript objects are not created off of a class the same way other programming languages work. And that's an important thing to understand because when we'll get into some of the details for people who are familiar with objects, things like object inheritance and relationships work differently. You don't have a class to say this class inherits from another class to get behavior. Objects inherit behavior from other objects, not from some sort of class hierarchy instead. That's a very different concept. And so if you try and force it to fit the existing models you're familiar with, it'll probably be harder for you than it will be if you almost approach it as if you're relearning objects. Questions about objects, what we talked about so far? All right. I think that's good for today. And then see you guys on Tuesday remotely. And I will be getting some stuff out. I might be trickling out over the weekend. So that way I can get some stuff out today, some of the ones that I already have written, and then work on some other ones to get out tomorrow as well for homework.